Oh, there you are. Welcome back to another episode of Chem Kids.
Today's topic is
Matter and energy. Matter and energy.
matter and energy.
And now for your PPE.
First things first, tie your hair back. Second, make sure you're wearing closed-toed shoes. Make sure you wear your gloves. Don't forget to always wear your goggles. And finally, always wear your apron. And now, you're ready to begin your experiment. Matter is anything that exists. Anything that has a definite mass and occupies a definite volume. Like my drink, for instance. You see, gases, liquids, and solids, they all matter. Hello, and welcome to Name That Matter. I'm your host, Sarah Bieber, and today we have Abby Hens as player 1 and Julia Folden as player 2. Alright, let's get this game going. Question 1 is worth 1 point. What are the two main categories that matter can be broken into? Abby.
Substance and mixture.
And that is correct! Alright, question 2. This is worth 2 points. What are the two types of substances? Abby Hens!
Elements and compounds.
And that is correct! Woo! On to question number 3. This one's worth 3 points. What are the two types of mixtures? And we've stumped our players. The answer is homogeneous and heterogeneous mixture. Alright, before we go into our fourth and final question, let's look at the standings. Abby has 3 points and Julia has 0. Now, if Julia answers this fourth and final question worth 4 points, she can take the game. Alright, question 4, worth 4 points. Which one of these is an amalgam? Is it a water solution, an alcohol solution, a mercury solution, or a metal solution? Julia?
Mercury solution?
And that is correct! Julia won the game! Energy is the ability to do work, which is using force to move an object over a distance. Whew. Man, this is taking a lot of energy.
It's important in certain experiments to take extra precautions. For example, in the experiment we are about to do, we need a hard hat. The law of conservation of energy states that energy cannot be created or destroyed, and when one object hits another object, energy transfers. We will now be demonstrating that for you.
Hello, and welcome to Julia's Kitchen. I'm Chef Julia, and this is my assistant Abby. Today we are going to show you some physical and chemical changes and properties by making some brownies. Tell us what we have here, Abby.
Okay, we have your brownie mix, we have your vegetable oil, your water, your eggs, and your mixing bowl, and a wooden spoon. Yep.
All right, we're gonna start by doing some mixing. All right, Abby, let's pour some of our mixture in there.
Alrighty.
All right, we have some brownie mix. You see how that's a nice
Powder.
solid, nice powder, yep.
Powder.
Sure is.
Sure is a powder.
Nice and dry.
Nice. Now we're gonna add some liquid to it because it flows.
This is our 2/3 cups of oil. Look at that.
Yes.
Got some nice moistening going on.
Don't say that. Don't say that.
All right, now we're gonna add our 1/4 cup of water. Yep. And last but certainly not least, we're gonna add 2 large eggs. Awesome. Good job, Abby. Now, Abby, can I have you stir this and mix it together?
First, I'm going to wash my hands.
That's right, because when you touch eggs are bad.
Yep.
Gotta wash your hands. So this is what we're doing. We're stirring this together and we're creating a mixture. Why is this a mixture, not a compound? Because technically it can be undone. So here we are mixing our ingredients together. Now, what we have over there in the process of being stirred into a mixture is a nice homogeneous mixture. But here's what we want. We don't want our brownies to be all the same all the way around. So we're gonna make it heterogeneous. And what that means is basically you can see its individual parts. And the individual parts we're gonna be able to see is the batter and our chocolate chunks. So let's make some chocolate chunks. Okay, our next step is putting our batter into our baking pan. Now what we have right now is a nice liquid. You can tell because it flows.
And it takes the shape of its container.
Yep, but it's got the same volume either way. So let's watch. Look how much space this fills up. Now let's put it into here. Look at that flowing. Nice, just what we wanted actually. Yep, that's what it's supposed to do. Look at that. So you see, we have a nice homogeneous mixture. You cannot see the individual parts. Now, my assistant Abby over here is gonna make this a heterogeneous mixture. Let's see it, Abby.
With what?
With those chocolate chunks. Wow, that's a lot of chocolate chunks in one spot. That's just what we want.
That's why we stir.
Abby's gonna stir
it
us
back up.
again. All right. That looks
Now
awesome.
Mix it.
Look at those individual parts.
That you could separate easily.
Yep, sure could. Okay, now you see we have our oven preheated. And this is the fun part, the chemical change. Thank you, Abby. All right, so we're gonna put this in the oven for about 20 minutes and we're gonna make some chemical change happen.
Lick the spoon.
Thanks for the help, Abby.
No problem.
See you in 20 minutes.
Alright, so with this experiment, we're going to... Okay, well, first of all, we have a balloon, a light colored balloon, blown up on the outside, covering a darker colored balloon on the inside. And with this magnifying glass, we are going to use the sun's energy to we're going to direct the sun's energy to the balloon, and if all goes as planned, the inside balloon will pop with the outside balloon staying as it is, because the inside balloon, its darker color, will absorb more heat energy, causing the electrons to buzz all around and collect too much heat and burst.
Just kidding, that's not what happened. Here's what actually happened. No! Well, that didn't go as planned.
What we think went wrong is that in the actual experiment, you're supposed to have a clear balloon on the outside and a black balloon on the inside. Obviously, that's not what we had, because we were going with what we did have at your house. So, we think if we had a clear balloon and a black balloon, it would have actually worked. But still, the energy from the sun popped the balloon. It just wasn't the right one. So,
Light energy.
light energy.
What's up? Now let's check on our chemical change. Smell that odor?
Woohoo!
That is a sign of a chemical change.
Look at that.
You see what we formed here?
Look at that.
We just formed a new substance. We formed brownies. This here is a physical change.
Thanks for watching. We're the Chem Kids.
And we'll see you next time when we talk about how excited we are for summer.
But now, we're out of energy. Let's take a nap, guys.
Sounds good.
Wow, guys, this is really good.
Thanks. Took a lot of energy.
Bucky Beaver!
Wait, Abby, say it again to me.
The ability to do work, which is using coerce to move an object over a distance.
Hi, Bucky. Who's my baby boy?
You have things to do over a distance.
It is important that sometimes you add.
You had what?
Okay.
Matter is anything that exists. Anything with a definite math. Math? What the heck?
You are a strong, independent woman.
I think I forgot to say 3 points. No, I didn't. We'll figure it out. All right. Question for. That was stupid. I can't believe that came out.
Question for
Go away. Okay.
It's with our chocolate chumps. Never lose your composure in the kitchen.
It didn't work. I didn't know what was happening.
How's it look? And now we're gonna go eat cheese pizza.
Yay! Cheese for the cheesies.
Have a great day, guys,
And what?
and always stay in the kitchen.
The law of conservation of energy states that something.
That energy can
They can drag me down. There's the cat.